All right, so here is an object that is the whole minus the holes. And you can see how we describe that, the whole minus the holes. And we're going to use the same table method here. But what we're going to do is divide this structure up into its composite shapes, if you will. Now, first of all, I'm going to give you some dimensions. We're going to say that this is a 2-foot radius. And let's say that it is located up at 4 in the y direction. This is 9 in the y direction, 9 feet. This is 4 in the x direction. Let's put a reference here. So this is going to be x going this way, and sorry about that, y going that way. Then this is also going to be 4 in the x, and this will be 10 in the x. All right, so what we're going to do is divide this object up into as many shapes as necessary to be able to adequately describe it using the table method. So here's one shape that I like. That's a rectangle. Then here's another shape that is a triangle. Then obviously the circle is another shape. And the way we're going to do that is we're going to take these pieces, add those up, and then we're going to subtract the whole using the table method. All right, so let's just draw the shapes. That might be probably the proper way to do it. I'll say that the first one is a rectangle, the second one is a triangle, and then the third one is a shape, and we're going to do that equals what we're looking for. Okay, let's build our table method, or build our table, and see what we can come up with. So let's call this part 1. This one will be part 2, and this one will be part 3. So table method, 1, 2, 3. Again, we're looking for x bar and y bar. So I'll put x tilde, y tilde. Now in this case, I don't have any weights or anything like that, so let's just use area. And the area is perfectly legitimate. X tilde area and then y tilde area. Whatever is uniform and appropriate for the picture or for the problem, you can use. Okay, so what is my x tilde of shape number 1? Okay, so here's my shape. This is 4 all the way out here. My x, or my centroid of that is right there, so my x tilde would be half of this distance, or just 2. What is the y tilde? Y tilde is, this is 9 up here, and this is going to be half of that, so that would be 4.5. What is the area? Well, the area is 4 by 9, so that would be 36. All right, let's multiply that all the way through, 72 and 162. All right, shape number 2. It's obviously a triangle. Let's go ahead and draw the centroid of a triangle. Here is a 1/3, 2/3 kind of situation. All right, for the x tilde, first I have to go this 4, and then to the centroid of the triangle. So the triangle looks like it is 6 in this dimension. So 1/3 of that would be 2. So here we have to go 4 plus 2, so that would be 6 in the y direction, or the x direction. In the y direction, again, we have the 1/3, 2/3 kind of rule here. So this is 9, that's only going to be up 3. What's the area? The area is 1/2 BH. A is equal to 1/2 BH. So that's going to be equal to 1/2 of times 6 times 9. So that's going to be equal to 27. All right, multiplying those out, I got 162 and 81. The last one is the whole. And in this case, the whole is round, which is handy. So that, well, first of all, let's use the x bar, y bar, or x tilde, y tilde. So in this case, it is 4 in the x and 4 in the y. And those are going to be 4 and 4. The area here, because it is a negative, because it's a whole, is negative. So what is the area? Area is going to be equal to pi. We'll just clean that up a little bit. Area is equal to pi r squared. And so that's going to be equal to 12.566. So that's going to be a negative area, so 12.57. Multiplying those out, I got negative 50.3 and negative 50.3. Again, same technique as before. I add the weights. In this case, I add the areas. It's 50.43. I add the x tildes. 183.7, 192.7. X bar is going to be equal to the sum of x tilde area over the sum of the areas. So that'd be 183.7 over 50.43. That's going to be equal to 3.64. And I guess I was calling this feet in the x direction. Y bar, sum of y tilde area over the sum of the areas. 192.7 over 50.43. That's going to be equal to 3.82 feet. So anyway, there are our two answers. Locations of the center of gravity. We could go back and look at that and see kind of where it's positioned on the picture, but they're both less than 4. So I guess it would be kind of right up in here someplace. That's where the actual center of gravity of our total structure is. Well, here's a three-dimensional one. Three-dimensional ones are handled in no different way. It just gives you more, I guess, more directions, more dimensions to consider. But let's see what it says. It says locate the center of gravity of the two-block assembly. The specific weights of the materials A and B are gamma A, 150 pounds per cubic foot, and gamma B is 400 pounds per cubic foot. All right, I am going to give you those pretty easily here. I'm going to say that the weight, okay, it gives you the which one is A and which one is B. This is A and this is B. All right, so if you recall, the weight of a structure is equal to the volume times the specific gravity. What is the volume of this triangle-shaped area? It should be equal to 1/2 BH, so it'd be the area of the side, times the thickness times gamma. All right, so I'm just going to give that to you. 1/2, the base is 6, the height is 6, the thickness is 2, the gamma is 150 pounds per cubic feet. But these dimensions are in inches. So we have to divide this by a factor to give it how many pounds per cubic inch. And we know that there are 1,728, which would be 12 cubic inches per cubic foot. Okay, that's a little bit drawn out, but I give that as 3.125 pounds. This is the weight of A. Similarly, the weight of B, I will spare you the details here, but you can calculate this. 16.67 pounds is equal to the weight of B. All right, so those are the first two pieces that we need to know. Now we're looking for the centroid, or the center of gravity of this entire shape. And to do that, we have to recognize that each of the composite shapes has its own center of gravity. So where's the center of gravity located of this triangle piece? Well, it's going to be 1/3, 2/3 in kind of in this dimension, and it'll be halfway in this dimension, if that can kind of make some sense to you. The center of gravity of the rectangle piece is probably not so hard to see. It should be halfway in X and Y and then halfway in the thickness too. So I'm going to erase my little markings here because those would just kind of be confusing perhaps. So but that was just kind of how I could explain it. Let's go ahead and write our table method. And so I have 2 parts, but I have 3 dimensions. So this is a long table. I have an x tilde, a y tilde, in this case a z tilde, a weight, x tilde z, x tilde w, y tilde weight, and z tilde weight. This will allow us then to calculate the center of gravity in all 3 dimensions. So we're looking for x bar, y bar, and z bar. All right, first of all, what is x bar for shape 1? It goes 2 in this direction, and then 1/3 added to that. So it'd be 2 plus 2, so that would be 4. In the y direction, what is it? It's going to be 6 up here. Oh, I'm sorry, I beg your pardon. Y is going in this direction. Oh, so this is 2 in the y direction. So half of that is actually just going to be 1. In the z direction, which is up this, is 6 high, should be up 2 in the z. All right, so I think I said those all correctly now without getting mixed up. I know that the weight is 3.125. And then let's go ahead and write in the numbers. All right, part 2. Bigger, weighs more. In the x direction, it has a center of gravity of just half of the thickness here, so that would be 1. In the y direction, it is halfway through the 6, so that would be 3. And in the z direction, it is halfway up. So again, pretty easy. And then we know the weight, 16.67, and let's multiply it out. And then we're going to add them up. Weights, these guys like that. Got 19.79, 29.2, 53.1, 56.25. All right, so we're getting good at this now. I'm going to zoom out just a little bit, see if I can get it all on here. I know that x bar then is equal to 29.2 over 19.79. Y bar is equal to 53.1 over 19.79. And Z bar is equal to 56.25 over 19.79. All right, so here are the answers: 1.475, 2.69, and 2.84. And those are all in inches as we get there.